Hello, everyone. This is Monitoring Analysis of Environment lab course. So this lab course is required for the senior level environmental science major at Virginia Tech. The class is taught in the spring semester every year with consistently 30 to 40 students. The students are taught on how to conduct water quality monitoring and soil quality monitoring. We use a local stream and a nearby agricultural field as our outdoor laboratory. The students conduct various hands-on projects throughout the semester at um, the water sampling sites as shown on the map on the left, as well as the field sampling site in this map. We also use the high frequency data collected by an Institute water quality monitoring station at one of our water sampling sites. The student learn a data-based assessment, decision, and communication. There are various essential data and analysis skills required um, for this class. But for today's module, I'm going to focus on variation in measured data to assess and communicate environmental test findings. So overall, teaching data science um, for this lab course, the challenge is that many students came into the class with very minimum training in basic statistics. Most of the students do not remember what they learned from the statistic class um, in freshman or sophomore year. So for this particular module, we focus on ANOVA tests and t-tests. Students were trained on the following skills: to use statistical method pertaining to an analysis goal, to compare results of analysis, to create a graphical representation of data based on statistical analysis, and to communicate concepts and findings using graphical representation of data. So 1 week before this module, the students were given some reading materials. One was a written instruction on how to use ANOVA and t-test. And then also I gave them 3 YouTube link where the student can find information on how to use Excel to conduct ANOVA and t-test. So during the class, first the students were given one data set, and the instructor explained how to analyze the data using ANOVA test. After the demonstration, the students were given one practical data set. The students were divided into smaller groups, and so they work um, within the with a classmate on doing the analysis of the data, and then they were given opportunities to demonstrate to other students what they have done and what questions they have. So after that, after this discussion, I gave them another demonstration of how to um, analyze the data. So this is a in-class example. So for this example, groundwater samples were collected from a benzene contaminated site. So the sample was split into 2 subsamples and given to 2 independent labs for independent analysis. The question is, do we see any difference between the data coming from lab A and lab B? And the confidence level I gave to the students is 95% confidence level. So this is the demonstration how to analyze the given data set. So I began with demonstrate to the student that if you manipulate Y scales, and it's easy to show that it looks like the data set from lab A is different from data set of lab B because the Y scale is so fine. Now, is this the correct conclusion or not? Well, we have to rely on statistical analysis. So I showed them how to do ANOVA test. And so the statistical data shows that actually there's no difference between the two data sets or the performance of the two labs. And then I showed them how to plot a correct um, graph to show the result. So, and I showed them how the importance of including standard deviation in addition to the average of the data from the two labs. So from this graph, as you can see that there's no statistic difference um, as indicated by the data analysis as well as the, the proper graphic demonstration. And I also demonstrate to them that you can use bar chart or you can use dotted chart. But regardless what format of the graphic uh, looks like, and including the average as well as the standard deviation error bar is a must when data set is communicated to um, your audience. So then the students were given a different data set um, for them to practice. In this case is um, at a Superfund site, two sites or samples, all samples from two sites were collected and analyzed. And the question is that, is there any difference in the lead contamination among the two sites? If there is, what are the site, uh, how are the sites different? So again, I demonstrated the procedures, how to conduct ANOVA test and t-test, and how to plot a proper figure to show the research, the test finding. So in this case, that site 2 has the highest level of lead contamination. And then the decision should be that if you have limited amount of money and you only can remediate one site at the time, and you need to start with site 2 and then move on to site 1 and 3. So throughout the semester, students collect water quality data and soil quality data. So for each um, monitoring task, they were given, they collect data. So we put the data together to form a super data set for the entire area where they conduct monitoring analysis. And then the data set is given to the students, and then along with a number of questions. And here is the example on their testing results for conductivity, total dissolved solid, and turbidity at 5 sites of this our retention pond, from inlet to outlet and downstream. So the data set from different group is compiled into the super data set. And so they conducted monitoring analysis on 1 day, and 3 days later, they went back and collect water sample and tested the data again. So here's an example that the questions that I asked them, with all of which are around analysis of the data set using ANOVA or t-test. For example, The first question is, what is your observation for those water quality indicators for the water collected along the 5 sites tested on one day? And then is it different that tested on the second day? So I asked them to provide graphical and statistical justification for their conclusion. Then I went on to ask them other questions related to um, linking their statistic analysis result to the environment. For example, the question number 3, comparing the conductivity of water at each site tested between the 2 days. Do you observe statistical difference between the 2 days at site site one? So what could happen in the town of Blacksburg between these 2 dates that might help explain your observation? So what happened was that there was a snowstorm uh, after the first water collection. So the snowstorm and the application of road salt actually affect the conductivity, turbidity in the water, um, even up to few days later. So they actually can link the change of the data with what's happening in the environment. So I use similar approach for other assignments based on their testing of other type of water quality indicators in soil, uh, as well as soil quality indicators. So this is how I deliver or include data science in my class. So thank you for listening. If you have any questions, please feel free to contact me at kxia@vt.edu. Thank you.